We take things to the extreme, and I'm pretty proud of it. But here's what we do. What we realized was the average utilization of the databases that we had, and we have tens of thousands of databases across all of our products and across all of our companies. We actually found that the average utilization was less than 2% on any of the resources that we were acquiring. Okay, and in enterprise workloads, a lot of these use cases or a lot of the workloads are very spiky in nature. Okay, they are not constant at all. So here's what we did. We spoke to the Aurora team and we literally asked them this question. At what point do you believe Aurora will fail? Okay, and they said, launch the biggest, largest Aurora 24XL, and here's the number of connections you can have. And if you need more connections, do read replicas. You can have up to 16 read replicas. So all your read operations, move it to the read replicas and go push it. I don't think you can break Aurora. That's literally what we got told by the Aurora team when Aurora first came. We were super delighted by it. So we did just that. We started piling on schema after schema. So every new database that we had, we would take the schema and just dump it into our centralized Aurora database. And we started hammering the hell out of it. Okay? We wanted to get our largest Aurora cluster to an 80% utilization. And this is a 24XL instance with read replicas, of course. Okay? And guess what? As we started piling on more and more of these database schemas onto the single Aurora instance, our marginal cost of adding a new database, 0. It was just going into the same DB. And the amazing thing that started happening with these individually spiky workloads was that we started seeing a flat utilization across the whole day, which is again awesome. But the most amazing thing that happened over here was each of the individual applications that leveraged the Aurora database or the new Aurora database started seeing a far better performance. And you know why? Because all of these different databases used to be much tinier databases. Some of them were T2 micros, some of them were small, some of them were larges, 4x larges, and so on. None of them were super massive or beefy like these. Okay, these machines have network bandwidth of, if I'm not mistaken, some of them have up to 35 Gbps network connectivity. You will get about between 12 and 30 Gbps EBS or local disk storage connectivity on these Aurora instances. So the connectivity, resilience, backup that happens under the hood with the storage, because storage and compute is separated with Aurora, all of those benefits came for free. Okay? So these applications were now using much beefier databases, adding 0 to our cost with every new added database, and we went up to adding over 2,000 schemas on a single database cluster. Okay? This is not something that we could have done any other way. And by the way, our database costs came down by 90%. I'm kidding you not, 90% was our reduction, because we needed massive teams of people managing thousands of databases all over the place. The performance had to be constantly managed, monitored, and so on. But by moving to Aurora and stacking it all up, we reduced our costs dramatically. So right now we are on the DBR5. We can't wait to get to the Graviton instances. Unfortunately, the Graviton instances still don't have the 24XL, because for our bin packing that we do, we really need the biggest, largest instance type we can get. We want the most memory, we want the most IOPS, and that's when this whole economies of scale works for Aurora for us. Okay? So here's an example of how the managed service helped us cut our costs dramatically.